Welcome back to the School of Laboratory Medicine. This is a poetic presentation which takes you through the famous Levey Jennings plot, a plot that we as laboratory professionals deal with on a daily basis. In my previous presentation, I had posed two word puzzles. The first one was, the price is good if it is on the target most of the times. The answer to this puzzle is the word precision. On target most of the times was the cryptic clue. The second puzzle was, if you take a tour all alone, you might have to lie outside the fence. The answer to this puzzle is outlier. You might have to lie outside the fence all alone was the cryptic clue. I shall now read out the poem, The Levey Jennings Plot. This was a poem that was published in the year 2013 in the journal Clinical Chemistry. This is the poem. The vibrant and dynamic Levey Jennings plot, with its unique display of dates, results, lines and dots, is a simple, comprehensive, nonetheless elegant chart. In internal quality control of labs, it plays an integral part. Right in the middle streams the golden mean. Above and below, three parallel lines are seen. 1, 2 and 3 times the SD values they indicate. Zones of white, grey and black they separate. Quality control samples are run for every analyte to ensure that the method is working all right. A minimum of 20 runs is first used to generate the data with which the LJ plot you shall create. At fixed intervals on each day, QC samples are run. The points generated are inspected once this is done. Does it fall within acceptable limits, rules and norms? Or is it an outlier causing the LJ plot to deform? Westgard has put forth guidelines that help us interpret conditions ideal for quality assurance that are to be met. Are we within the limits or have we strayed out? Is there a rule that our data happen to flout? Under ideal conditions on the graph should be seen values randomly distributed on both sides of the mean, crisscrossing the middle several times during the week. No deep valleys should be seen and also no tall peaks. When a single QC result strays beyond the 2S boundary line, there is no reason to panic. Things might still be fine. We need not withhold patient results as this is just a warning rule. Until we look at the result in the next run, we can stay cool. A single QC value that appears beyond the 3S boundary line goes against the 1-3S rule and shows that all is not fine. It indicates a random error or the beginning of a trend. Until you troubleshoot patient's results, you shall not send. If two dots appear in tandem and both of them exceed the sum of mean and twice SD, you shall not proceed. The 2-2S rule is invoked. Patient's reports put on hold until corrective action puts it back on the right road. If two successive controls cut across the 2s on opposite sides, a random error has occurred. By the R4S rule, we must abide. If four consecutive control values lie next to next in a row, above or below the 1s limit, a violation of 4-1s rule they show. If 10 consecutive points of one level QC all lie on one side, or 5 of two levels of QC are on the same side of the divide, the 10x rule is violated. Root cause analysis needs to be done, corrective actions instituted and checked, patient samples rerun. The QC line sometimes takes an upward or a downward trend. At times it shifts towards one side after an abrupt bend. It might even show a drift just before the next calibration is due. Each one of these has a hidden story from which we must get our clue. Maybe a reagent has deteriorated, or the feed water conductivity high, or a fibrin clot has blocked the sample probe, or the calibration has gone awry. A faulty temperature sensor might cause the thermostat to malfunction. A failing light source, a blocked or warped tubing might need your attention. We are indeed lucky that these charts give us an early clue. When we drift off at a tangent, when trouble strikes out of the blue, it ensures that we cry wolf only when there is really one in sight, and not set off on a wild goose chase when things are actually all right. Checking and maintaining quality is a matter of daily grind, a routine worth every minute spent, its purpose well defined. We owe it to our patients to give them precise reports, and to our clinician colleagues a reliable diagnostic support. We have to be aware of the harm that might be caused to the patient, so risk mitigation strategies must not be paused. The planning and execution of QC we need to strategize. The number of out-of-control events we should drastically downsize. Let us live within the secure towers of the Levey Jennings fort and learn to treat the Westgard rules like the castle moat. As long as you're confined within it, you are safe and sound. If you step out too often, there is loose soil on the ground. So now we come to the take-home points. The Levey Jennings plot is an integral part of the internal quality control plan of medical laboratories. The key features of the LJ plot are the mean and the standard deviations all appearing as parallel lines above and below the mean. The values for the mean and SD are obtained by running quality control samples for a minimum of 20 times. QC samples are run on a daily basis. The run is rejected if there is a violation of the Westgard rules, which are the following: the 1-3s rule, the 2-2s rule, the R4s rule, the 4-1s rule, and the 10x rule. The other important observations that need to be made are the trends and the shifts which could occur. When there is a violation of a rejection rule, patient's results are withheld, root cause analysis is carried out, corrective actions are taken, QC samples are rerun to check for the acceptability, and patient samples are rerun before the reports are released. Thank you for your patient listening. We look forward to seeing you again in our next session of the School of Medical Laboratory Sciences with another poem. Your feedback is solicited.
Here is my email ID. Thanking you once again and hoping to see you soon.